Hi, I'm Dipjyoti. I'm the leading author of this paper, Universal Multi-Speaker Multi-Style Text-to-Speech Synthesizer based on Disentangled Representation Learning. With the recent advancements, the text-to-speech synthesizer or TTS systems are capable of generating very good quality speech. However, it is more on the neutral side and less expressive. So we can build a universal multi-speaker multi-style text-to-speech synthesizer using speaker information and style information. So we can add the speaker encoder and style encoder along with the content encoder. However, there are some problems which we need to address. The first problem is content leakage. The content leakage is when we expect the content information from the content encoder, but we get that from either style encoder or speaker encoder. And the same goes for style leakage, where we expect the style information from the style encoder, but we get it from content encoder or speaker encoder. So if that happens during inference times, the performance deteriorates. In order to mitigate that, we propose a new technique or new loss based on Rényi divergence. So we call it Rényi divergence estimator. So we calculate the loss, which is basically nothing but the mutual information, and we try to minimize that. So we calculate this mutual information loss between two pairs so that we can get this distinct or disentangled information. So if we use style encoder and content encoder and we use the loss between these two, and we minimize the mutual information between these two, so that we can get only style information from the style and content information from the content. And that goes for the speaker encoder and style encoder. So we use this mutual information based loss along with the reconstruction loss, and we train it in an adversarial way, where we can see here the loss. We also show objective evaluation tests and subjective tests to justify our claims. We use mean square error for the F0s. We use Mel-Sepstrel distance, and we use word error rate. In all the objective cases, we can see the proposed technique performs better. We also show objective test based on cosine similarity for the speaker similarity test, and we see that our proposed techniques are more or less same as the baseline techniques. However, we show some subjective evaluation test based on MOS scores. So we perform two tests, speech quality and style similarity, and both the cases we can see that our proposed techniques is much more better than the baseline universal TTS or baseline TTS with mutual information mined. Thank you very much.